So this question is a question from the SAT digital, the digital SAT question bank. And there's an error in this question in which all of the answer choices are hidden. We can't tell what they are. So what I'm going to do here is first of all, I'm going to make up some answer choices. Let's just make this x to the 16th, y to the 16th. Let's make this x squared, y squared. Let's make this one xy to the 9/7 power, and let's make this one xy to the -2 power. Okay. Second of all, I'm going to see that this question looks like it's going to be a simplified question, right? It has all the behaviors of a simplified question. It's short. It has an expression provided for us. So let's just take this expression provided and see, well, how would I simplify this? 9th power. So the way we simplify radicals typically is to take a look at the type of radical we have. So we have a 7th root. Look at how many times it goes into each of our terms under that radical. In this case, 7 goes into 9 once with 2 left over. So a good way to kind of visualize what I'm doing here before I make the shortcut of just showing you the answer, which would be xy 7th root x squared y squared. A good way to visualize how we get there is this. I can turn this into the 7th root of x to the 7th times x to the 2nd, which of course would be equivalent to x to the 9th, times y to the 7th, y to the 2nd, which of course is also equivalent to y to the 9th. And then all I'm saying is that a 7th root of x to the 7th power brings an x out. And 7th root of y to the 7th power also brings a y out. So that's where this x and y came from. But of course, you see we still have an x squared under the 7th root, and we still have a y squared under the 7th root. So that's where this comes from. So that's not, sometimes that can be difficult to see, but hopefully that description and explanation makes sense. The issue with this is we don't see that, and we don't see that in our answer choices, right? So we don't have this option as an answer choice. So the question is, you're taking a test, you do this work, you don't see your answer. What do you do then? I like to suggest that instead of thinking that you made a mistake, because in this case, you actually would not have made a mistake. This is definitely an accurate statement in terms of equivalence to our original here. Instead of thinking that you've made a mistake, let's think, is there some strategy that I can use? Is there some strategy that maybe helps me to think about this in a different way so I can still find the answer? And if not, I'll star it, come back to it later on and see if I can, figure out how to do this with fresh eyes. In this particular case, there is actually a strategy. So I'm going to erase everything that I have here so far. I'm going to show you the strategy. So there's a strategy called plug in your own number, PIYON, plug in your own number, that says whenever I see variables in the question and I see variables in the answer choices, I can make up my own numbers, right? So in this case, let's do that. If I said x is equal to 2 and y is equal to 3, I've just made up my own numbers. Now, the way the strategy works is it's a 3-step process. The first step is to take those numbers that I've made up and plug them into the original question. So let's do that. I'd have 7th root, 2 to the 9th, times 3 to the 9th. I can take this to Desmos, plug that in, 7th root, 2 to the 9th, times 3 to the 9th. And what Desmos tells me as output is that this is equal to 10.011062, ... Keeps going. Okay, so that's step 1. Step 2 is to, actually, I take that back. I'm going too fast. Step 1 is to make up the numbers, right? I try to stay small. Step 2 is to plug those numbers into the question. Step 3, our third step, is to plug those numbers into our answer choices and find the match. So for instance, if I'm trying choice A, I would say, well, is it true that 2 to the 16th power times 3 to the 16th power is equal to this 10.011062? And when I put that into Desmos, I see that that is not true. It is not equal to that, so A is gone. Is it true for choice B that 2 to the second power times 3 to the second power is equal to this 10.011? And I see also there that that is not true. You can just probably figure that out on your own. That's definitely not true. So that's why B is gone. Let's try choice C. So when I try choice C, I say, well, is it true that 2 times 3, right, because those numbers by each other just means 2 times 3, to the 9/7 power, which means I'd have 6 to the 9/7 power. I throw that into Desmos, and guess what I get? I get the exact same value that I had when I plugged these numbers into the original. I get 10.011062 and the same values after that 6.2. So that automatically tells me that choice C is at least a runner-up. I like to always try all of my answers instead of just assuming C is correct. So, but at least C is not crossed out. So then choice D, I'd say, well, is it true that, so this is D, is it true that 2 times 3 to the negative second power, which gives us 6 to the negative second power, which would just be 1 over 36, right? So that is not equal to that 10.011 number. So we confirm that choice C is the best answer via using this strategy of plug in your own number. So that's a great strategy to use. Hopefully it makes sense on how I got to choice C as the best answer there. I can show you mathematically how to get choice C as an answer as well. I can say this 7th root of x to the 9th, y to the 9th. I can simplify what's under the radical in terms of putting those the x and y together and calling that just a 9th power, right? Like these two things are equivalent. X to the 9th, y to the 9th is the same as xy, parentheses, to the 9th power, because that 9 outside the parentheses applies to both the x and the y. Second of all, a 7th root is the same as a 1/7 power, right? So the 7th root can be converted into a fraction power of 1/7. So then again, this is equivalent to this is equivalent to that. Then when I simplify this, I can multiply my exponents here. So I'd have 9 times 1/7, which will give me my xy in parentheses to the 9/7 power. And that's what we have for choice C here. All right, so this process, even if you can see how it's true now, is probably pretty difficult to think about as a first step when you're first doing this. Maybe you do think of it, maybe you don't, I'm not sure. But the strategy of plugging your own number, knowing that you can use that in any given situation where there are variables in the question and variables in the answer choices, that's a golden ticket, right? Like that is a golden strategy that you can use regardless of how the question is set up.